Hello students, in this presentation I shall continue with the topic objects as function arguments. I have already discussed about the pass by value method in my earlier presentation. So now I am going to discuss the topic by the help of pass by reference method. Now here is a sample program. You are going to find this program under the section pass by reference in your book. This program consists of a class identified by the name employee. These are the data members declared as public, and this is the member function input underscore data, which is also declared as public. So these members can be easily accessed from outside of this class. The class body ends here with a semicolon. The function input underscore data shows abstraction because its implementation details are hidden inside the class employee. They are not shown here. Instead, they are defined outside of the class with the help of this scope resolution operator. The program is going to start from the main, as main is the inception of a C++ program. As it enters inside the body, I can see two variables HRA and DA getting declared, whose data type is float. But if you notice clearly, these two variables, that is HRA and DA, are also declared inside the class known as employee. So these variables HRA and DA, as they are declared outside of the main function, we can consider these variables as global variables. And of course, these are the data members of this class employee, but in relation to these two variables which are of the same type, that is HRA and DA, they are different. This is because these two HRA and DA variable are declared inside the main function. So these are the local variables. But as these two HRA and DA variables, since they are outside of the main function, they shall be treated as global variables. Now the question is that how can you distinguish between these two global variables of HRA and DA with these two local variables of HRA and DA? The local variables of HRA and DA inside the main function shall be represented exactly like this. So these are the local variables. But these two global variables of HRA and DA has to be represented like this. Both these variables has to be preceded with the help of the scope resolution operator. So these two variables of HRA and DA represent these global variables, and these two variables of HRA and DA represent the local variables. Now at the time of declaration of these global variables inside the class employee, we don't have to put the scope resolution operator. Only if we try to access these global variables from inside the main, I have to precede those two variables with the help of the scope resolution operator, like this. That means if you look at these two statements here, I am trying to update the value of the variable DA by 1.2 into EMP salary, and then I am going to update the value of the variable HRA by 0.15 into EMP salary. When I try to perform this updation, the changes will be reflected only in these two local variables. That means with the help of these two statements, I am making changes only to the local variables of HRA and DA. I haven't touched the global variable of HRA and DA. But if you want the changes to be reflected in these two global variables of HRA and DA, then instead of putting these two statements like this, I shall precede the variables DA and HRA with a scope resolution operator like this. Then once the updation is done with the help of these two statements, this time I am not going to touch these local variables. Instead, I shall be making changes into these two global variables. So as of now, let's not put these two scope resolution operator. I shall keep it exactly how it was printed in the book. So I am deleting these two scope resolution operator for now. Now this is totally local. That is, these two variables of HRA and DA represents these two local variables. Okay, now let's come to the next statement. In the next statement, it defines another variable named gross whose data type is double. So three variables have been declared inside the main function. Those are HRA, DA and gross in the first step. Then in the next step, an object specified by the name xEMP has been created from the class employee. Now as soon as I create this object bearing the name xEMP, these data members and this member function shall be bind to the object known as xEMP. So these data members and this member function input underscore data has been bundled into a single unit to form an encapsulation, and then this encapsulation has been tied to the object xEMP. As a result, these data members and this member function shall operate upon this object xEMP. So once the encapsulation process has been done upon this object xEMP, the object then tries to access this member function input underscore data. If you see this member function input underscore data, this has been declared as public. So the permission to access this member function input underscore data has been granted to the object xEMP. And when it starts accessing the member function input underscore data, it passes these parameters from this calling function into this call function. So the value 100, which is the parameter in the calling function, shall be copied to the parameter e underscore code in the call function. Similarly, the value ms Sujata in the calling function of input underscore data shall be copied into the parameter e underscore name of the call function, and then the parameters pgt computer and 12,500 in the calling function shall be copied to the parameters e underscore basic and e underscore salary respectively in the call function of input underscore data. So to put it simply, all these parameter values in the calling function of input underscore data shall be copied into all these parameters in the call function of input underscore data. As a result, from there we are going to have e underscore code as 100, e underscore name as ms Sujata, e underscore basic as pgt computer, and e underscore salary as 12,500. But if you look at this function, its implementation part is outside of the class, that is over here. So now for this function with these parameters, I have these statements in the implementation part. So here the value of the first parameter e underscore code shall be assigned to the data member emp code. As the value was 100, So 100 shall be assigned to EMP code. Again, the value of the data member E underscore name, which was MS Sujata, shall be copied into the data member EMP name through the help of strcpy function. Similarly, the values of the data members E underscore desig and E underscore salary, which were PGT computer and 12,500, shall be copied into EMP desig and EMP salary. So EMP desig is going to take the value PGT computer that is coming out of this parameter E underscore desig, and the data member EMP salary is going to take the parameter value that is coming out of this parameter E underscore salary, and that value is 12,500. So 12,500 shall be assigned to this data member EMP salary from E underscore salary. As a result, after executing these implementation steps, I can see that the values of E code, E name, E desig and E salary getting copied into EMP code, EMP name, EMP desig and EMP salary. So check both these. Their values are exactly the same. Now, as EMP code, EMP name, EMP desig and EMP salary denotes the data member of the class known as employee, so these values assigned to these data members shall represent the state of this object XEMP. So here it is, we get the current state of the XEMP as this, and these values determine the current state of this object XEMP. The data member EMP code, which is assigned the value 100, occupies 2 bytes of memory space. This is because the data member EMP code has the data type int. Again, when the parameter value MS Sujata gets assigned to this data member EMP name, 20 bytes of memory space shall be allocated to this data member. This is because the data type of this data member EMP name is char and its size is 20. Since char takes 1 byte, so 20 into 1 gives 20 bytes. Again, when the parameter value PGT computer gets assigned to the data member EMP desig, 15 bytes of memory space shall be reserved. Since EMP desig has the data type char, which occupies 1 byte, so 1 into 15, which is the size of this data member EMP desig, gives the total as 15 bytes. And then from here, since the value 12,500 has been assigned into this data member EMP salary, whose data type is float, so 4 bytes of memory space shall be reserved for this data member EMP salary, because the float data type occupies 4 bytes. Now, if you sum all this up, you can determine the total memory space that need to be allocated for this object called XEMP. Now the sum total gives 41 bytes. So 41 bytes of memory space shall be reserved for the object XEMP. Now look over here, even though I shall be calculating the values for the variables DA, HRA and gross, I shall not be taking into account the memory spaces that shall be reserved for these variables, because these are the local variables of DA, HRA and gross. which have just been declared inside the main function. If I have to take the HRA and DA for calculating the memory allocation for the object XEMP, then I have to take these two global variables of HRA and DA, not these two local ones. For that, I have to precede the DA and HRA with a scope resolution operator like this. Now if we do so like this, then along with 41 bytes, I have to take 4 bytes for HRA and another 4 bytes for DA, because both HRA and DA were of data type float. Because these two format of DRA and HRA represents these two global variables of HRA and DA, which is this that has been bind to the object named XEMP. So adding 4 bytes for HRA and 4 bytes for DA adds another 8 bytes. Okay, it adds another 8 bytes to the object XEMP, which gives 49 as the total number of bytes that shall be reserved for this object XEMP. But as of now, I am going to remove these two scope resolution operator from the variable DA and HRA to make these two variables as local variables, because your book is pointing to these local variables only, that is these two type of HRA and DA, which have been declared inside the main function as local variables. And then we can't take these global type of HRA and DA variable, which was bind to this object XEMP during encapsulation. So now we have to ignore these two variables, due to which I am going to deallocate 4 bytes for HRA and another 4 bytes for DA. So now it's going to remain as 41 bytes only. Okay, so the memory to be allocated for this object XEMP shall be 41 bytes if we consider these two as local variables in these two statements. Clearly these are local variables because they haven't been preceded with the scope resolution operator. Okay, so that was all for your understanding. Okay, so you remember I left at this point through which I have copied these parameter values from this calling function of input underscore data to the parameter values of eCode, ename, edesig and eSalary in the call function of input underscore data, which gives these as the values for the parameters eCode, ename, edesig and eSalary in the call function. And from these parameters, the same values gets copied into the data members EMP code, EMP name, EMP desig and EMP salary, and that gives the same values for the data members EMP code, EMP name, EMP desig and EMP salary, which were assigned to the parameters eCode, ename, edesig and eSalary. So look properly, they are exactly the same. Now these values assigned to these data members indicate the state of the object known as XEMP. So the state of the object XEMP is indicated by these values which are assigned to its data members. And once this function body builds the state of the object XEMP, the control is again going to move to this point just after this statement. Now with the help of this statement, I am creating another object by the name EMP, which creates a reference to the object XEMP, and the reference is denoted by this ampersand symbol. This is the ampersand symbol which creates the there was a disturbance. Okay, this is the ampersand symbol which creates a reference to this object known as xemp. So from here, as soon as I have created an object bearing the name emp out of this class employee, I have also created a reference to the previous object xemp. That reference is denoted by this ampersand symbol. Now when I create a reference from the object emp into the object xemp, then both these objects, that is emp and xemp, they are going to share their memory locations. Okay, both these objects emp and xemp, they are going to share their memory locations. Now sharing the memory location gives us some idea that both these objects emp and xemp, they denote the same entity. Because if they would have been a different entity, then they would have taken different memory locations. But now they are not utilizing different memory locations. They are actually sharing their memory locations. So we can say that the object emp, when it references to the object xemp, is actually pointing to its address. So both these objects emp and xemp, they are going to share the same address. In short, we can say that the object emp is an alias to the object xemp. So any change that is reflected in the object emp shall also be reflected in the object xemp. Now if we see our living world, a person can have two different names. One can be his real name and the other can be his alias name. Say for example, if there is a person bearing the name John, which is his real name, and then he also has his alias name, which is David, then John and David, both these names, they are pointing to the same person, and we can point that using John alias David. Okay, where John is his real name and David is his alias name. Or we can also point it like this: John Akka David. Okay, now that same concept that exists in our living world shall be applicable to these objects as well. Now in this case, if the new object emp is an alias to the old object xemp, then both their states must be exactly the same. If for any reason you change the state of one object known as emp, the state of the other object known as xemp is also going to change. As a result, we can conclude that the changes in the state of the object emp shall also be reflected in the object xemp, because they both share their memory locations. And this we can denote it like this: the state of the object emp alias xemp, because the object emp creates a reference to the object xemp. So these values that indicate the state of the object xemp shall also be applicable to the object emp. Any change in these values associated with these data members shall reflect both these objects emp and xemp. So that's the concept of pass by reference. The pass by reference method has created a reference to the object xemp through the object emp. Now once this statement gets executed, I can see the state of the object emp and xemp indicating the same values for its data members. It then moves to the next line. Okay, it then moves to the next line and calculates DA, HRA and gross. Now these three variables of DA, HRA and gross, these are the local variables because they have been declared inside the main function. And since I'm not preceding these variables with the help of scope resolution operator, so I'm not pointing at these global variables. Instead, I'm only pointing at these local variables. And once I compute DA, HRA and gross with the help of this formula, I get the value of DA as 50,000, HRA as 1875 and gross as 29,375. Then the control moves to the next statement, which prints this text. Here is the employee information into the output like this. Then it is printing the equality symbol 32 times in the output as shown here. Just after the text, here is the employee information. Then with the help of these statements, it's first printing the value of employee code, okay, that is represented by the value of this data member EMP code. So the text employee code is shown here, and then the value of the data member EMP code, which is 100. Okay, so it prints the employee code and then the value of the data member EMP code, which was 100. So employee code and 100. Then it prints the text employee name into the output, followed by the value of the data member EMP name. As the value is MS Sujata, so it prints employee name and MS Sujata into the output like this. Then it prints the text designation, which is within inverted code, into the output. Sorry, it shouldn't be employee designation, it should be designation, because the text shown here is designation. And then the value of the data member EMP desig, which was found to be PGT computer. So designation PGT computer gets displayed in the output. Then the next statement prints the text basic salary into the output. Sorry, it shouldn't be employee salary, it should be basic salary. And then the value of the data member EMP salary, which was found to be 12,500. So basic salary 12,500 gets displayed in the output. In the same way, it prints dearness allowance 15,000, house rent allowance 1875 and gross salary 29,375, because the values for the data members DA, HRA and gross has been calculated and found to be these. And after this step, the program ends here. Now if you see this program logic, the program logic is based on a real world application where you get to input the employee details, which are 100 as employee code, Sujata as employee name, PGT computer as employee designation and 12,500 as the basic salary. And once you input these employee information, you broadcast this information pertaining to the employee in the output in this format. And that's the end of the program. So that was all about the pass by reference method. And with this, I end my today's presentation.